Bismillahirrahmanirrahim. Assalamu alaikum student and welcome in college physics. So student आज हम डिस्कस करेंगे the derivation of parallel axis theorem, that is rotational inertia I equal to ICM rotational inertia about center of mass plus mh square, mass of the object, and h square is the perpendicular distance between two axes. One axis passed through the center of mass and other axis is any arbitrary axis which is parallel to the center of mass axis. So आइए स्टार्ट करते हैं कि पैरेलल एक्सिस थ्योरम क्या होता है और एग्जाम में इसके नोट्स को हमने किस तरह लिखना है। पैरेलल एक्सिस थ्योरम स्टेटमेंट कुछ इस तरह है। द पैरेलल एक्सिस थ्योरम स्टेट्स that the moment of inertia of an object about an arbitrary parallel axis can be determined by taking the moment of inertia of the object rotating about an axis through its center of mass and adding to that the total mass of the object multiplied by the square of the perpendicular distance between the center of mass axis and the new arbitrary parallel axis. The parallel axis theorem expresses how the rotation axis of an object can be shifted from an axis through the center of mass to another parallel axis any distance away. Mathematically, the parallel axis theorem is this one, where I is the rotational inertia about arbitrary axis, ICM is the rotational inertia about the parallel axis through the center of mass, and m is the total mass of the object, and h is the perpendicular distance between the arbitrary axis and the center of mass axis. इस फिगर को देखें, ये हमारे पास कोई भी एक ऑब्जेक्ट है और इसका जो सेंटर ऑफ मास है इस ऑब्जेक्ट का वो है ओ डैश पर, यहाँ पर. नाउ द रोटेशनल इनर्शिया अबाउट दिस ओ डैश means about this axis is what this is I center of mass. If we draw another parallel line, this one, and this parallel line pass through any point O, and we are interested to find out the rotational inertia of this object about this point O, so the rotational inertia of this object about this point O is I, and rotational inertia of this object about this O dash, which is at center of mass, is ICM, plus m is the total mass of this object and h is the perpendicular distance between these two parallel axes. याद रखिए ये ऑब्जेक्ट जो है ये हमारे पास कोई सॉलिड सिलेंडर भी हो सकता है, ये हमारे पास कोई स्फीयर भी हो सकता है या कोई रिंग भी हो सकता है. Now you are interested to derive this relation which is known as parallel axis theorem. तो आइए इसकी डेरिवेशन को स्टार्ट करते हैं. नोट्स में इसकी डेरिवेशन को हमने यहाँ से स्टार्ट करना है. As shown in the figure, a thin slab in the xy plane which can be regarded as a collection of particles. We wish to calculate the rotational inertia of this object about the z-axis which passes through the origin O as shown in the figure. Let's consider a small element on the slab which mass m at point P. The perpendicular distance between point P and the z-axis is AP. Now the moment of inertia of mass m about z-axis is what? I equal to m multiplied by r square. R square is the distance between axis of rotation and any point mass. तो इस फिगर को देखें, ये हमारे पास कोई भी एक स्लैब है, एक आर्बिट्ररी ऑब्जेक्ट है और इस ऑब्जेक्ट के इस पॉइंट के अराउंड हमने रोटेशनल इनर्शिया को मालूम करना है. तो हमने क्या किया, हमने यहाँ पर जो है यह एक्सिस हमारे पास जो है सेंटर ऑफ मास एक्सिस है और इस सेंटर ऑफ मास एक्सिस के हमने पैरेलल एक और आर्बिट्ररी एक्सिस को ड्रा किया विच इज़ डिनोटेड बाय जी, और हमने इस जी के अराउंड जो है रोटेशनल इनर्शिया को मालूम करना है. सो हमने इस ऑब्जेक्ट पर एक स्मॉल इस होल ऑब्जेक्ट पर एक स्मॉल मास को कंसिडर किया which is m. This m is r distance away from the center axis, and this m which is ap distance away from this arbitrary axis. Now, according to the definition of rotational inertia about this z-axis, I equal to mr square. So here r square means this whole distance, the distance between this arbitrary axis and this point P. So AP, the distance between this M and this arbitrary axis is what? AP. So moment of inertia I equal to M into AP whole square. But this AP is what? This AP is equal to AB plus BP, where AB is H and BP is our R. So rotational inertia I equal to M AP whole square या M into H plus R whole square. Now moment of inertia पर whole slab will be what? ये तो हमारे पास rotational inertia है इस small m के लिए, लेकिन ये ऑब्जेक्ट जो है, ये स्लैब जो है, ये वेरियस स्मॉल पार्टिकल m पर मुश्तमिल है. तो इस होल ऑब्जेक्ट के लिए रोटेशनल इनर्शिया क्या होगा? दैट इज rotational inertia for this whole object is I equal to sigma m, this for a whole object, into h plus r square. Now using a plus b whole square equations, we obtain sigma m into h square plus r square plus 2rh, या I equal to h square sigma m plus r square sigma m plus 2h sigma mr. Now this sigma m means mass of the whole object, which is denoted by capital M. So this become mh square, and this sigma m mass of the whole slab या object, which is denoted by capital M. So this is mr square. So rotational inertia of the object, is what? Mh square plus mr square. But this mr square is known as, this is rotational inertia about center of mass. So this become ICM, and this mh square is mh square. Now this term is equal to 0. Summation of all. Now this term, summation of mass into r equal to 0, because this show the sum of moment about center of mass, which is always equal to 0, because a pair of opposite mass balance each other. मिसाल के तौर पर ही हमारे पास जो है सेंटर ऑफ मास ओ डैश है, यहाँ पर एक ऑब्जेक्ट है, उसका नाम है m, वो r दूरी पर है. तो इसका एक अपोजिट यहाँ पर ऑब्जेक्ट होता है m, और वो भी r के दूरी पर होता है. सो मीन्स बोथ आर एन अपोजिट, सो इट बैलेंस ईच अदर. सिमिलरली दिस पॉइंट बैलेंस ईच अदर. यहाँ पर एक और पॉइंट, यहाँ पर हम पॉइंट रखें यहाँ पर, तो दिस पॉइंट एंड दिस पॉइंट बैलेंस ईच अदर. सो इट मीन्स द नेट मोमेंट of all these small objects about this O dash must be equal to 0. Now some application of parallel axis theorem. Problem 1. Find the moment of inertia of a solid cylinder of mass capital M and radius capital R about a line parallel to the axis of the cylinder and on the surface of the cylinder, as well as for solid sphere about tangent. क्वेश्चन में कहता है कि हमारे पास ये एक सॉलिड सिलेंडर है और इसका जो सेंटर ऑफ मास होता है अबाउट दिस सेंटर एक्स एक्सिस, दैट इज आई इक्वल टू 1/2 mr स्क्वायर. क्वेश्चन का डिमांड ये है, अगर हम यहाँ पर एक लाइन को ड्रा करें जो बिल्कुल इस सिलेंडर को यहाँ पर टच करे, तो इस अराउंड के, अगर इस लाइन के अराउंड अगर हम इस ऑब्जेक्ट को रोटेट करना चाहते हैं, तो इसकी रोटेशनल इनर्शिया हमारे पास क्या होगा? सो दिस इज ए center of mass axis, and this is a arbitrary axis which is parallel to the center of mass axis. So apply the parallel axis theorem. The total inertia about this yellow line, I equal to I naught, rotational inertia of the cylinder about a center of mass, plus mh square. I naught is what? This is rotational inertia of the cylinder about its center, so that is mr square by 2, and m is mass of the cylinder, and h square is what? Perpendicular distance between these two, and the perpendicular distance between these two is equal to radius of the cylinder. So here we insert r square, so mr square by 2 plus mr square, if we add we obtain 3 over 2 mr square. This is the rotational inertia of the cylinder of mass m if a line drawn parallel to the cylinder on its surface. It means the rotational inertia of the cylinder will be increased at this surface point. Now rotational inertia of a solid sphere about this line, and this line is tangent to the sphere because it touches the sphere at a single point. What will be rotational inertia of this sphere about this line? So again, using the definition of rotational inertia, that is I equal to I naught mh square. I naught is what? This is rotational inertia of the solid sphere about its center of mass, which is equal to 2 over 5 mr square. And again, the distance between this tangent line and this center of the sphere equal to r. So again, replaced here h by r. So we obtain I equal to I naught mr square, 2 over 5 mr square plus mr square. By adding this, we obtain 7 over 5 mr square. Again, rotational inertia of the object of solid sphere will be increased if we rotate this about this line. Next problem है, what will be rotational inertia of solid rod about its center of mass? About its center of mass, that is I equal to 1 over 12 ml square. So what will be rotational inertia if someone rotate this at this point? Means at the end. What will be rotational inertia of this solid rod about this point? So this is our arbitrary axis, which is parallel to the center of mass axis. So using again parallel axis theorem, that is I equal to ICM plus mh square. ICM is what? Rotational inertia of this whole solid rod, which is equal to 1 over 12 ml square. And about this point is the whole length of the rod is L. So this distance will be what? L by 2. So rotational inertia will be what? I equal to ICM plus mh square, and h is the perpendicular distance between this axis and this axis, which is equal to half of the length of the rod. So here replace h by L over 2. So by simplifying this, we obtain 1 over 3 ml square. This is rotational inertia of this solid rod about its end point, this point or this point. Now इस प्रॉब्लम को देखिए, प्रॉब्लम 3. Two identical solid sphere of mass m and radius r are joined together, and the combination is rotated about an axis tangent to one sphere and perpendicular to the line connecting them. What is the rotational inertia of the combination? हमारे पास दो स्पेयर है, एक ये है और एक ये है, और हमने इसकी रोटेशनल इनर्शिया को मालूम करना है अबाउट दिस एक्सिस. तो याद रहे कि हमारे पास स्पेयर है, तो इस स्पेयर का रोटेशनल इनर्शिया अबाउट दिस सेंटर ऑफ मास क्या होता है? 2 over 5 mr स्क्वायर. इसी तरह इसका रोटेशनल इनर्शिया अबाउट सेंटर ऑफ मास क्या होता है? 2 over 5 mr स्क्वायर. सो लाइक masses, rotational inertia of solid object add like scalar. So the total for the two sphere is what? I equal to I1 rotational inertia of this sphere plus I2 rotational inertia of this sphere. For the first sphere, which is close to the line, by using parallel axis theorem, rotational inertia of this sphere above this one is what? I center of mass plus mh square. Here I center of mass means 2 over 5 mr square plus mr square. Mr square means this is the central axis, this one the central axis, and this central axis is r distance away from this tangent line. So this become mr square, or by adding this we obtain 1.4 mr square. Now rotational inertia of this sphere is what? I2 equal to ICM plus mh square. ICM is rotational inertia of the sphere 2 over 5 mr square, and this distance, this is 1 r, this is other r, and this is other r. Means this center of mass axis is 3r distance away from this point. So this is our h. H means h equal to 3r. So 2 over 5 mr square plus m into 3r square equal to 9.4 mr square. Now adding this rotational inertia and this one, so we obtain total rotational inertia I equal to I1 plus I2 equal to 10.8 mr square. So it is clear if we have two solid sphere and we join these two like this one, and we want to find out rotational inertia about this line, then rotational inertia of this both body about this line must be equal to 10.8 mr square.